Okay, so looking at number 2, what we have is write the equation in standard form. So we're talking about the standard form of the circle, which if we remember is x minus h squared plus y minus k squared equals r squared. So we have a center of hk, so it's the opposite sign in there, and then it's equal to radius squared. So we look at what we have. We have the center, we have the radius. We're actually set. We're able to plug this in. So I have x instead of minus 1, it's the opposite, so it's plus 1 squared plus y. Instead of positive 7, it's going to be a negative 7. So y minus 7 squared equals. And this is going to be our radius, 14 squared. Going to leave the left side just like it was. And I'm just going to square the 14, which we already know is 196. That's my answer there. Okay, so looking at number 14, the only difference here is the fact that they give you a diameter instead of the radius. So this is actually also cool what happens when there's a 0 here. So it's x minus 0 squared plus y minus 9, opposite signs, remember, equals. Now, we don't have the radius. However, we do have the diameter, and we know the relationship already. This is double the radius. So I'm going to take this 32, which is my diameter, and I'm going to divide it in 2, giving me 16. So radius is equal to 16. So I'm going to put 16 squared in here. Okay, so we actually can do something over here. Because of the fact that x minus 0 is just going to be x no matter what, okay? So this is x squared. So we don't even need to put the 0 in there whenever we're given 0 here. Doesn't matter if it's x or y. In this case, it was x. If the 0 was over here, this would just be y squared. So here, y minus 9 squared equal, and then we go 16 squared is 256. That's my answer there. Looking at this next one, they give us center and the radius. So it's x minus 15, it's the opposite here, plus y plus 6. Remember, it's opposite sign, equals radius squared. So it's the 158 squared. So we have the square root of 158, and that's squared. Two ways to think about this. If we think what's opposites here, square root and square, they'll end up canceling out, leaving us with 158. We saw this when we were rationalizing, remembering the special right triangle chapter where it would be something like 2 over this. So this is completely different, but this is what we would do, and we go, okay, well, the bottoms, square root of 2 times square root of 2 ends up being the square root of 4, which is equal to 2. Remembering, when you multiply them by themselves, it ends up being just the number. The square roots cancel out. So here, that's what happened when I squared the square root, ended up canceling out. So I'm going to cover that up just so that you guys know it's not part of this problem. So x minus 15 squared plus y plus 6 squared equals 158, and that's my answer. This next one gets pretty cool, the next two. So it says write the equation in standard form. We're given center and circumference. I'm going to fill out whatever I can. So I have x minus 9 squared plus y minus 12 squared equals. I don't have the radius. What I'm giving is circumference. So let's use what we have. What we have is circumference. So I go, okay, circumference equals 2 pi r. I can plug this thing in right there. So we're substituting. So I have 17 pi equals 2 pi r. Okay. I want to get r by itself. Currently it's multiplied by 2 pi. To undo that, I'm going to divide by 2 pi. Divide by 2 pi. And if you guys do remember these, you did have to put parentheses if it's more than just 1 pi, because of the fact that if you plug that in your calculator, it will end up doing some funky stuff. So if you want it, anytime it's dividing by multiple pi, always put them in parentheses. Over here, it ends up canceling out. And why the parentheses don't matter too much on this one is because I'm not going to put this whole thing in my calculator. I'm going to say that pi's end up canceling out. So in our heads, we can do that. What's 17 divided by 2? That's 8.5. So that's equal to just my radius, okay? So now I have radius. I can plug it in here. This isn't just radius, it's radius squared. So I'm just going to simplify over here. I get x minus 9 squared plus y minus 12 squared equals 8.5 squared, which is 72.25. That's my answer there. Last one on this kind of set. So only difference here is they're given area instead. Let me set up. It's x opposite sign, so minus 2 plus y plus 2. Opposite sign equals, we don't have the radius. However, I have the area. Let me think. Area is equal to pi r squared. I have area. That can go right in here by the property substitution. So I have 361 pi equals pi r squared. For whatever reason, sometimes when you guys do plug in area, you forget the pi. Make sure if it does have a pi, you keep it there. Reason why is it makes this problem a lot easier. Plus, it would be wrong if it wasn't. So we're going to get r by itself. You cannot square root yet. You want to divide by pi. So let's get pi away first. Divide by pi, divide by pi. Pretty nice. Both of them cancel out. I have 361 equals r squared. And then all I'm going to do from this point is square root. Don't worry about the negative version of it. I know normally we think, okay, plus or minus. Doesn't work. For right now, we're just talking about length. We want just the positive. So the square root of 361, which I'm just going to leave right now as the square root of 361. Here's why. That's my radius. Let's just plug it in. If I leave it with the square root, I look, okay, those two cancel out. I have x minus 2 squared plus y plus 2 squared equals 361. That's my answer there. Okay, so looking at number 12, I apologize in advance for this awful circle. However, I don't have graph paper, so did the best I could. So write the equation in standard form given the poorly drawn graph. Really what we need to know is what do we need when we're looking for standard form? Well, you need the center and you need the radius. Let's start with the easy one, the center. I just count -1, +3. So -1, 3. Radius, how do you find the radius? You count from the center to a point on the outside. You don't want to count diagonal. Let's go straight, either up, down, left, or right. I generally either go this way or this way. I'm going to go to the left this time, and I just count. So it's 1, 2, 3, 4, 5, 6, 7. I double check, mainly because of the fact that sometimes these graphs are a little bit harder to read. So sometimes I go, okay, let's check this way. 1, 2, 3, 4, 5, 6, 7. Nope, both of them are 7. So my radius here is 7, okay? Remember, this circle is equidistant from any of the points, but we're just gonna check these 4, okay? So I have my radius, I have my center. Let me fill out my equation. So I have x, opposite sign, so +1 squared, y, opposite sign, -3 squared equals 7 squared, which in this case is going to be 49. Okay? Number 14, write the equation of the circle in standard form given. So what they're giving us is the center, which in this case is 1, -5, and a random point somewhere on the circle. I'm gonna put it over here mainly because your notes has it drawn with the point over here, okay? Now here's the thing, most likely it's actually somewhere like here, here, it's not gonna be straight across, so you can't just count like I could in the last one. Let's look what we can do, okay? Looking at what we actually have from a different chapter is going to be, it's actually section 1.3 if you remember. We have distance formula, which is the one that we memorized. So we have x2 minus x1 squared plus y2 minus y1 squared. This is distance, so you're finding the distance between 2 points. The other thing that we're going to end up needing is midpoint. Think averaging here. So the midpoint is equal to the average of the x's. So x1 plus x2 divided by the amount, so 2. Averages of the y, y1 plus y2 over 2. So that's midpoint formula and distance formula. You're going to be using these. I look. You want standard form. I need 2 things. The center, which I have. And the radius. But here's the thing. The radius is just the distance between these 2 points. So what I'm going to do is I'm going to do distance formula on these 2. Remember, for sake of just making sure we don't make those little mistakes, I'm going to label these points. So I'm going to say this is x1, y1, x2, y2. And I'm going to plug in. So this is going to be the distance formula, okay? So I have big square root. x2, remember anytime it's negative, we're going to put it in an extra set of parentheses. So x2 is negative 7 minus x1, which is 1. I didn't really need that extra set of parentheses there. Sorry, guys. Plus y2, negative 13, minus y1, negative 5, squared. Don't forget your squareds. It's a positive in the middle, and these ones are subtraction. Okay, so negative 7 minus 1 is negative 8 squared plus negative 13 minus negative 5 becomes a positive 5. So negative 13 plus 5 is negative 8 squared. Anytime you take a negative and you square it, it's always going to be a positive. So I have 64 plus 64. Almost there. Radius is equal to the square root of 128. For right now, I'm just going to leave it like that. I have my center and I have my radius. I'm going to work with these 2. I'm going to plug it into my equation. So here, if I have x minus 1 squared plus y plus 5, remember opposite signs here, equals this thing, which is the square root of 128. We're squaring it. Those cancel out, leaving you with the final equation, x minus 1 squared plus y plus 5 squared equals 128, and that looks beautiful. Okay, moving on. Last one that I'm going to do with you guys is the kind of hardest one. It's not hard, it's just tedious. So it's going to take a little bit of time. Let's think about the concept here. So it says write the equation in standard form. So yet again, the 2 things that I need is the center and the radius. Given the endpoints of a diameter. Important things to think here is, how do you get a diameter? It has to go through the center. That's really important thing here. It's going to go through the center. So I'm going to draw this. I'm going to label my 2 points. So let's put 6, negative 13. I know it's not really drawn out well. This is probably not right here, but we're going with it for right now. Just going by the concept. You have these 2. Am I given the center? Absolutely not. Am I given the radius? Also a strong no, okay? But let's find it. So the first thing I need is, for me to find radius, I either need this length or this length. I have no center. Let's find that first. How am I going to find the center? Well, this is the endpoints of a diameter. Finding the middle, we have an equation for that. It's going to be midpoint formula. So let's start with finding midpoint of this. So I'm going to label x1, y1, x2, y2. Okay? Then we're going to find the midpoint. So midpoint, averages of the x's. So 6 plus -2 divided by 2, averages of the y. -13 plus 15 divided by 2. It's a point. Midpoint is equal to, this is going to be 4 divided by 2, and this is going to be 2 divided by 2. Keep going. Midpoint is equal to, that's 2, that's 1. So perfect. I have my center. The midpoint in this case is also going to be your center. So we are halfway there. Okay? Now I just kind of want to pick one of these 2 points. The reason why is I want the radius, okay? So I'm going to either go with these 2 and find the distance there, or these 2, find the distance there. I'm going with these 2. I don't know why. I just like the numbers more. Okay? So the thing about this is this might change how you label them. So I would then use a different color probably to label these next 2. I'm going to go, okay, well this is 2, 1. I'm going to say that's now x1, y1. And this over here is going to be x2, y2. Okay? And I'm just going to use those. I want the distance between them to find the radius. So I have radius is equal to distance formula. So big square root. And then we're going to go x2 minus x1 squared plus y2 minus y1 squared equals, simplify, -2 minus 2 is going to be -4 squared plus, that's going to be 14 squared. Radius is equal to, that's 16 plus 169. I am totally lying here, 196. I apologize for that. 196 here, okay? And we're going to add them together. And in this case, I think we get 220 or 212, I think it is. Yeah, 212. Actually could have had that in my head. Did not realize that. Sounds good. So we have our radius is the square root of 212. Okay? That is going to be the last thing that I really need in order for me to plug this in. Okay? So I'm going to go, okay, I now can do my equation. I have x opposite sign, so -2 squared plus y opposite sign minus 1 squared equals, and this is the square root of 212 squared. These are going to cancel out, square root and the squared, they're opposites. I'm left with x minus 2 squared plus y minus 1 squared equals 212. That's it.